Okay, ladies and gentlemen, this video is on using trigonometry to solve right triangles. Trigonometry, better known as SOHCAHTOA. And hopefully you're familiar with SOHCAHTOA. And if not, well, follow along and I'm sure you'll understand. Okay. So here's a problem I gave last week on a worksheet, and notice that we have a missing angle over here. I'm going to call that little x. Okay, so little x will be that missing angle. What's the next step? Well, the next step is you got to label the sides of your triangle. This 21 over here, for instance, notice, is across from x. It's on the opposite side of x. Okay, so that's what we call the opposite side. The 42, notice, is right next to x. That's what we mean by the adjacent side. A for adjacent. So, if we take a look at SOHCAHTOA, we will notice, hopefully, that tangent, that's what the T right there stands for, tangent is the function that uses opposite and adjacent. And that's what we have here. We have the opposite side right here, and we have the adjacent side right there. Okay? So knowing that we have the opposite and adjacent side, and knowing that we are going to use tangent, well, let's do the math now. We know that the tangent of angle x somehow equals 21 over 42. Again, 21 is the opposite side, right? The opposite side. Whereas 42 is my adjacent side. See the TOA right there? Tangent is always opposite over adjacent. Okay, so what do we do next? Well, here's where we get our calculator, and we're going to divide this 21 over 42. So we know that the tangent of x is 0.5. Now what do we do? Well, to find x, we're going to do what we call the tangent inverse. Okay, a little messy there. Sorry about that. The tangent inverse, that's what that little -1 means, on both sides. And so what does a tangent inverse do is it's going to cancel out the tangent function because they're inverses. And notice I'll just have x equal to the tangent inverse of 0.5. Using the calculator now, I now know that x will equal the tangent inverse of 0.0 or 0.5 will equal 26.6 degrees. And we'll just round that off. Sorry, I was a little messy there as usual, unfortunately. We'll just round that off to 27 degrees. And that's basically how it's done. So pause the video and make sure you understood basically what I did, and then we'll pick up the pace a little bit. Okay, so you notice now we'll of course pick answer D right there, right? 27 degrees. Okay, here's the second problem that was on my worksheet. So, first thing we're going to do is label our missing angle x. You could call it any letter you want, by the way, but I happen to like little x's. And now we're going to label our sides. And now hopefully you understand that the 19 is my opposite side again. Okay? And the 29 is what we know as the hypotenuse, right? Yeah, that's the longest side, the hypotenuse. Well, let's take a look at SOHCAHTOA again. Notice this time, if I know I have the opposite and the hypotenuse, well, what uses opposite hypotenuse? And if you look close enough, you'll realize, hey, that SO part uses opposite hypotenuse, right? And that S right there stands for the sine of the angle. The sine. Okay? So, now that we know it's the sine, where do we go from here? Well, we know that the sine of x somehow has got to be 19, which is the opposite side, right? Divided by the hypotenuse, 29. And similar to the last problem, how do we solve for x? Is we're going to do the sine inverse of x on both sides. Sorry, I don't have a lot of room here on my screen, but I'm going to do the sine inverse and post a picture of my calculator right now. So as you can see, the sine inverse of 19 over 29 is 40.93, but of course we'll just round it off. So x is basically 41 degrees, okay? And then of course we will pick answer C over there. So pause the video again and make sure this makes sense. Okay, one more problem, but this one is a little different, if you see. Notice this time we're missing the side. Now that side x happens to be the adjacent side, right? Notice how it's right next there to the angle 67. So this time we know the angle, we're missing a side. Okay, well, also notice the 18 is what we would call again the opposite side. So going back to SOHCAHTOA, notice we need a function that uses opposite and adjacent. What uses O and A? Well, hopefully you agree it's tangent. Our friend tangent is always opposite over the adjacent. Okay, so now that we know tangent is the one we need, we have that the tangent of 67 degrees, remember sine, cosine, and tangent always go with angles. So we know that the tangent of 67 degrees is the opposite over the adjacent. Okay, so notice how this is a little upside down over here, right? And so we're going to do a little algebra trickery here. What we're going to go ahead and do is let's go ahead and put tangent of 67 over 1, and then let's just cross multiply. I'm going to cross multiply here. So does everybody agree, hopefully, that, let me give myself some more room here. Hopefully you agree that x is now going to times tangent 67, and that somehow equals 18. The 1 times 18 right there is 18. And to find x now, we are going to divide by tangent 67. Divide by tangent 67 degrees. Okay? Okay, so hopefully you can see my little picture of my calculator. I did 18 divided by the tangent of 67 degrees, and I got 7.64. So we'll round that off again. Sorry about that. And x, therefore, is 7.6 units, rounding it off. And of course, therefore, we would pick answer B. So that concludes a little intro to using trigonometry to solve right triangles.